So let's start the webinar. I hope I am audible. Can someone confirm?
Yes, Pranav.
Yeah. Okay. Okay. So today's topic is material model and the material calibration in the SIMULIA 3D experience. Let me introduce myself. I am Pranav Shukla. I'm working as senior simulation engineer at the engineering technique. And if I give you a brief about the engineering technique, then engineering technique is the Dassault System business partner company, which is also called the valued VAR, which is also known as the VAR of the Dassault system. Okay, so let me go with this the contents. So these are the contents I'm going to cover today. First one is the stress versus strain curve. So to give you a brief about the stress versus strain curve, then what is the meaning of the engineering stress versus the true stress thing, and then about the what is the material model and what are the constants. Then what is the material calibration app in the Simulia. Moving forward, then I will go with the computational modes available in the material calibration app, as well as the number of material models are available in the Simulia. Material model constant calculation with the material calibration application. This is I will showcase you how to calculate the constants. Then the material model in the setup and the result. So how to set up this material this model, and how to extract the result with the help of the whatever we define this material using the material calibration app. Moving forward, then I will showcase you the material model constant calculation with the manual method. I will give you a brief how method is used for the this manual method. Then I will showcase you the how what are the takeaways, and moreover, also I will give you a brief about the damage modeling. So there are number of material model on the damage parameter also available. So I will give you brief about that as well. So moving forward. So this is the well-known figure about the stress versus strain curve. So if I give you the brief about this particular thing, then let me on this pointer. Yeah. So as you can see, this portion is we can consider is the elastic region, and this globe is also known as the Young's modulus. Okay, this globe is also known as the Young's modulus. This portion is the yield one, and moving forward this region is known as the plastic region. The plastic zone is known as, and this region, the strain of the material is increased. So that's why it's known as the strain hardening region. When it reaches to ultimate strength, and then it start the necking is start, and after that at one point the fracture will occur. Okay, so this is the brief about the stress versus strain curve, which we have seen number of time. Okay, so moving forward with the engineering stress strain and the two stress strain. So difference between this engineering stress strain and the true stress strain is that we get the laboratory test data in form of the this particular the engineering stress versus strain thing, and we need to calculate this thing. So in the engineering stress versus strain, they consider the initial area. On the other hand, when we go with the true stress versus strain, so in that the actual area when there are we expand this thing, then the area will change with respect to time. So we consider the current area at the moment. So this is what the difference is. So and these are the equation with the help of with this equation you can calculate the engineering stress and the engineering strain, and these are the equation where you can calculate the true strain and the true stress and the true strain. Okay, so this is what the difference is. I just want to showcase you this thing. Moving forward, so there is a question perhaps in your mind that what is the material model and the constant and the constant. So material model is nothing but the mathematical representation of the material. Okay, so if you see over here, this is one equation which is called the material model equation, and material constants are the unknown which need to find out to solve the equation to understand the material model behavior. So if you are if you see able to see over here, these are the constant a, b, and n. These are the constant which are the unknown and which need to be calculated with this help of this material calibration thing. So this, I hope you understand what is the material model. So this one is the material model equation, mathematical form, and the material constant which we have to calculate with the help of either material calibration app which is available in the SIMULIA, or you can go with the manual method as well. Okay. So moving forward. So what is the material calibration application in the SIMULIA 3D experience? So working in the elastic zone, we needed a very fewer material data. For example, the density is there, then the elastic Young's modulus is there, then the yield strength is there. So these are the data is enough to calculate the stress and strain displacement, all this stuff in the elastic region. But when you go with the plastic zone, then things may, become the complicated. So when it comes to the plastic zone, number of material models are available in the market with the different kind of softwares. Okay, so there are number of material models are available, and for each material model, we need to find out the material constants. And with the manual method, this take may longer time, and there is a chance of the human error. Okay, so in the material calibration application helps you to find out the material constant of the different material model, and it also help to compare which material model behavior is near to the material lab test data. I will showcase you that thing into the software. In the other word, it helps you to compare the material model curve with the test data curve to finalize which one is more near to the material test data. Okay. So overall, this can be done in the fewer clicks, and the material constant can be calculated in the few minutes. Whereas on the manual, it may take the days or the weeks, depends on the expertise of the person. Still, there is a chances of the human error. Overall, material calibration application in the SIMULIA 3D experience is the time-saving application for the R&D professionals and the research scholars. Okay. So in this particular material calibration app available on the SIMULIA 3D experience, there are the computational modes and the material models are available. So when we talk about the computational modes for the computing the material, there are the three modes are available. First one is the analytical, which is the fastest option, supports the calibration for the fewer material models. Then is the second one is the numerical model. The first one is this, you can see over here. The first one is the analytical one. Second one is the numerical one, which is this slower, provides the support for the more material models. And the third one is the FEM base, which is the slowest of all three, but the greatest range of the application for the models and the material behavior response, the complexity. I will showcase you that in the material calibration in this actual software. Okay. When we talk about the material models, so there are the different kind of physics are available. So there is a linear elastic is there, the elastic plastic is there, viscoelastic is there, then hyperelastic is there, hyperform is there, viscoplastic is there. So in all this on all this stuff, there are different material models are available. So here I have showcased you about the metal. If we talk about the metal, so Johnson Cook is there. Okay, there are the other different material models are available over here. On the other hand, if I talk about the hyperelastic thing, there are like rubber. Okay, so in the rubber form, there are the number of material models are there like Neo Hawkini, Ogden is there, Munilivrin is there, Yo is there, Marlowe is there. So there are the different material models are there. So I will showcase you today about the one material model, which is the Johnson Cook calibration of the 1018 steel. And this is the procedure where you have to create a simulation, then you have to import the test data, then you have to process the test data, run the calibration, and review the result and create material. So let me just showcase you like the Johnson Cook calibration of the 1080 steel. So this one is the test data, and if you see over here, this one is the Johnson Cook material model response, and this one is the test data. I'll open this material model thing into the Simulia, and I'll showcase you the procedure step by step. So it will help you to understand how we can perform this stuff. Okay. So here you can see over here, this one is the test data. Okay. So what I have to do is I have to go over here and I have to just click over here, then the test data. Okay. This one is the test data. Sorry. Just to go over here, this one is the test data. And this one is the sheet. Now click on the next. I have to define this one is the nominal strain. So these are the nominal strain thing, and whatever they are here is available, it is nothing but the uniaxial nominal stress data, which is into the megapascal. Okay. So I just click over here next, and these are the strain rate, total time, and this one, which is you see in the uniaxial testing machine. So I just import this thing. Now, this one is the okay, and just import this thing and close. Okay. So now if I click over here, then I'm more interested what you can do over here. Like here you can see there are the few data is there that you can just want to delete. Like I just don't want this uh this stuff to be a straight. Okay, so you can just click this stuff over here and click delete to make it more straight and linear. Okay. So you can play with this stuff and uh, try to correct as much as possible as per your requirement. So here I just want the data from until this one only. So I just delete this data. I just want the data up to the you can say the ultimate strength only. So I just click this and I also here. Now what I can do, I can do the zero shift. I just make it to 0 and I just click the data, this data, and click evaluate. Click it yes. So it will shift to 0. Just reset the zoom. Now it is shift to 0. So this is what you can do and play with this stuff from here. You can repair this thing or the data you want. You just want to delete, so you can delete this thing. So you can play with this stuff from here. Okay. So I just click over here, click OK. Uh, you can also yeah. From here you can also play with this stuff like I just want this thing to the nominal strain, so it will change to nominal, and just want this thing to be a nominal stress, so it will change to nominal stress. And if I want this chart legends to be on the bottom to be at the bottom, so it will not reflect over here, so it will showcase you in the bottom. So this one is the uniaxial test, so you can play with this stuff from here as well. Okay. So this one thing is done now. The next step is the material model. So here I have to select the this one, the analytical, the numerical model. Okay. So in the numerical model, there is option is available, the linear plastic, elastic plastic. So I have to create this elastic plastic thing. Okay. And let's click OK. Okay. So now in the elastic plastic thing, as you can see, there are the different material models are available over here. So I just wanted to compare this Johnson Cook thing with the manual method. So I just showcase you over here. So in the Johnson Cook material model, these are the main thing which you need to calculate either by using the manual method or using this particular method of the SIMULIA 3D experience on this material calibration thing. So if you try to calculate this stuff with the help of manual method, it will take a huge amount of time. Then there is chances of the human error there. Okay, but this SIMULIA 3D experience has the material calibration app which help you save a lots of amount of time. As you can see, I just select the material, this particular import this particular data and just select the elastic plastic thing, and I just choose this particular material model over here. Okay, now what I have to do is I have to just click over the execute. So what once I click this execute thing, it will try to calibrate this material model with the your particular this test data. So let me change this thing to the black. Okay, so it will help you to understand. So this one is your data of the test data. Okay, reset to zoom. This one is your test data, and this one is your response of the material model. So with the help of the material model, you will understand that how your test data is near your material model is near to your test data. So ultimately, it will give you assurance that this material model is quite accurate to use for your analysis purpose. So what I will do now, I just make this particular material, and I will use this particular material for the analysis purpose. So then it will give you give me a more realistic result. If I go with the any other material model and that material model will not give me a near about the result of this particular test data, then I can't use that material model for my analysis purpose. So this is what you have to check, that your material model is near to your test data, your behavior is how the behavior is there. Okay, so as you can see, by the one click, this material model calculate this particular constants. Okay, and here you can see the accuracy. You can say accuracy of this particular thing, like it is give you a 98% accuracy of this particular match with the test data and your material model. Okay, so now the next step is to create a material. So just gives the name of this particular thing. So Johnson Cook material model, which I use in webinar. So I just use this thing. And this one is for the steel. Just click OK. So it will create this particular model. And as you can see, all this test data, this constant has been calculated and it is shifted over here. So, and also you can provide the density, whatever the density is, like 850 kg per meter cube. You can provide that thing. But, okay, so this is how it is calculate the plastic stone, plastic thing and Johnson Cook data. Now moving forward about the how to use this particular material. So I just showcased you. So I just whatever I have showcased you over these two test data and the Johnson Cook material model response. Now moving forward. So this Johnson Cook calibration. This one is the equation. The A, B, and this one is two, and you have to calculate this particular three thing. And as you can see, this particular three data has been calculated with the help of just few clicks. Okay. And I will showcase you the portion of the manual later on, so you will understand how this particular multi-calibration app is useful to you. You okay? So I will showcase you this thing into the uh, this particular thing. So if I okay, and I just import this particular model. Okay, I just open this thing. So this one is the one tube is there which is made up of this steel, and I have to just compress this thing. So until this non-linearities comes into the picture. Okay. So I will try to address this thing, and I just try to set up this thing into the this particular SIMULIA UI. I just showcase you how to set up this thing. Okay. So to create the structure, and no, I will do the mesh later on. Just click over here. Yeah. Here I have to select the procedures about the explicit thing, and apart from that, into the part portion, you can use this particular this assistant panel to set up all this stuff. So in the part portion, you have to define this model, this like top plate. This one is the solid section. You can define the material. Anyhow, I just make anyhow I will use random any material. And just use any material over here because I will make it rigid only. So without plasticity, top plate. This one is the bottom plate. Without plasticity. Okay. I will use this one, top plate. I will make it rigid. This one, bottom plate. And I just make it rigid. Okay. So this one is done. Now the next step is we have to mesh this stuff. So I will mesh. Okay. One thing is remain again, the main portion, this one. So in this portion, whatever the material I have created currently in this material calibration app, I will use that material over here. So it will help me to get the more accurate result. Okay. So in session. So in this session I have created recently. This material, if I showcase you, this particular material model contains, sorry, all this data which we have been calculated with the help of Johnson Cook thing into the material calibration. Okay, so this is what I have applied over here. The material has been applied. Okay, now the next thing is the meshing. So we have to create mesh initial geometry. So it will calculate by its own. The hex mesh is done for this portion. This one again is done, and for this portion it will calculate, and meshing is done. The mesh portion is done. Now the connection is not required. Interaction is nothing but the friction thing. So you can apply the friction like 0.5, for example. I'm applying the friction between these parts, and here you can apply the general contact. Yeah, you can apply the 1 second into the particular this one. Fraction. Let me see. Okay. So it will behave like a bonded thing over here currently, and I can use this particular general contact and use this particular contact property which I have used. Now moving forward with this particular clamping. So bottom thing will be the bottom plate will be fixed. So just clamp the bottom thing. Okay. And the top one, the top plate, which is moving into the only y direction, and the remaining direction will be the fix. Okay. And the next stuff is what you have to do is you have to provide either the load or the displacement. Here I am applying the displacement. So here distance between this particular distance is 50 mm. So what I can do, I apply the -45 distance over here, -45, and I have to select this top plate. So it will move into the -y direction using this translation of -45. So 5 mm will be the distance between these two plates at the end of the analysis. So here, whenever you use this thing, explicit thing, so you have to define the curve. So at the 0, the load will at the 0, load will be the transition will be the 0 ultimately, and at the 1 second I have used the step time is the 1 ultimately. So at the 1 load, the displacement will be the -45. Okay, so you have to define this thing into the translation. Okay, then it will be check. So this one is the setup is done. The setup is done, as you can see. So once you run this setup, I have already run this thing over here. So I will showcase you the result because it will take a time. So this one thing I just want to showcase you over here is, for example, if you want to run this thing, so there is two options are there. One option is the local. So ultimately you can run this analysis of the explicit analysis either with the local thing, or you can run this thing with the cloud option. Also, we in the particular this high-end simulation with this you can say the role. I will showcase. I will mention the role later on. Like FGM role is there. The durability mechanics engineer role is there. So in the durability mechanics role, the 8 core you can use the 8 core totally free. Like credit or token is there, you can use the totally free. But if you want to go beyond the 8 core to run the analysis on the cloud or on the local, so it will charge you some amount of credit or some amount of tokens. Okay, either you can use the even this one. So even this one you can use the 8 core. 8 core is totally free in the token and the credit. And beyond the 8 core, if I go with the 9 core, So that will use the 1.5 credit per the hour. So credit is nothing but like the recharge. Like we can you are using the mobile phones that are recharge is there. So once the recharge is over, you have to do the recharge again. And if we talk about the tokens, so there are the tokens which is reusable. So you buy some tokens, it will use the some tokens for the analysis. Once the analysis is over, the token will be the again to the bucket. Okay. So there are the two things are there. So this is what the difference is there. Like you can run this thing into the cloud. So ultimately, when the analysis is quite complicated, if you put this analysis on the cloud, then it will be really helpful. That they use the system, they use the this hardware and the software, so hardware stuff of the Amazon AWS thing. So ultimately, your system will be the free. You can use your system for the other work. And if you use the local thing, so it will stuck your system and you have to run this system. You have to run the analysis over here. So it will take more time to run this thing, because your system perhaps not that capable to run the analysis faster. So and the Amazon, the AWS has the quite new updated hardwares are there into this server. So that analysis run faster in their cloud portion. So this is the benefit, I can say, to run the analysis on the cloud. Okay, and if I showcase you the result, so let me showcase the results. So it will take a while time to see the result. Wait for a while. It will download this thing from the cloud. So as you can see, you can calculate ultimately how the behavior will be there. Like at the 1 second, the behavior will be like this one. I just use okay. So this is how it will compress your steel tube, and this one is your stress data, and this one is your plastic strain thing. Like this one, the plastic strain is developed while compressing this stuff. So ultimately, the goal of this particular webinar is that you can you if you have the test data, you can use your test data and calibrate your material using this material calibration app, which is available on the SIMULIA 3 experience, and calculate the constant which needs to calculate for the material models. And later on, you can use this particular material model into the analysis to give you a more accurate results. Okay. So if I go over here and again showcase you this one. So this is what I wanted to showcase. Like the tube crust is there. So setup I have showcased you, and the crust result I have showcased you how you can use this material model into the similarity experience, and you use particular for the analysis. Now moving forward. The material model constant calculation with the manual method. Okay. So if I talk about this manual method stuff, then if you see over here, this one is the Excel file. So as you can see, this one is the lab data, the engineering strain and the engineering stress lab data is there. Okay, this one you have to calculate the true stress versus true strain. You have to calculate with the equation which is mentioned in the previous slides. Okay, so you have to calculate this stress strain versus stress data over there. You can also may need to calculate the offset with need to calculate this Young's yield point using the offset to percentage to offset. Then also you have to calculate this true stress versus true strain data, which is mentioned over here. Now, ultimately you have to use calculate this stuff with the help of this particular equation. And once you use this equation, as you can see, this equation has been used to calculate this particular curve. Okay, so in this particular curve, I have used the linear, only the linear one, and with the help of the linear line, like y is equal to mx plus c. So okay, so with the help of this particular thing, yield is has been find out like 265 with the previous one, and the strain hardening exponent as n is find out with the help of this y is equal to mx plus c, which is nothing but the 0.128, and the strain hardening exponent b, which is find out with the 554. Okay, 554, which has been find out over here. For that, I have used particular this expression, and this expression has been used for, and this constant has been used to find out this particular exponent. So this method has been used, and you can also you need to you can say this line. If I showcase you over here. So here I use the only the linear one, but if the linear one is not working and not giving you the perfect result of this constant, you can play. You have to play with this exponential thing, logarithmic and polynomial thing and power stuff. You have to play with this stuff over here. So for this thing, I can say that expertise is needed. Very much expertise is needed, and if a person is lagging in the expertise to find out this stuff, then there is chances of the human error, and you can say that whatever the constant you have find out with the help of this particular method, the manual one, there is chances of the human error for this sure. But whatever I have showcased you into this material calibration app, in this particular material calibration app, there is a you can say there is 19 percentage of the accuracy if your data is pure. Okay, so this is what I want to showcase you that ultimately you can find out either with this particular method. For that you need expertise, and on the other hand, similar 3D experience has the capability to find out this thing with the few kicks. So if I say this particular in my experience, I try to find this stuff, this constant. I took almost like 1 week to find out this particular constant. I was doing for the first time. So if there is a not experienced person is there, then there is a chances like well, no doubt the human error, but there is chances of the huge time to find out this particular constants. Okay, this is what I want to showcase you. And apart from that, you can find out the different constant. But you need lots of the access skill for to find out this constant. As you can see, like there are different constant. I have tried to find out. This one is nothing but the Johnson Cook damage model thing. There is damage thing is also there, and there is the only the Johnson Cook is also there. So that different models are available. I will showcase you the brief about the damage models also available in the similar 3D experience, and how the damage model will work. So I will showcase you that also later on. Yeah. So this is what I wanted to showcase the material model calculation with the manual method. So if I talk about the takeaways of this particular thing, so material model constant finding with the manual method is the time consuming and needed more expert person. Also, there is a still chances of the human error. Material model constant finding with the material calibration application is quite easy and no expert is needed over here. Even you can compare the lots of material model as I showcased you previously, like there are a number of material models are available. So you can just quickly check like which material model give you a more near result with this data, and you can finalize that particular material model for your analysis out of them. Okay. So and moving forward, there is another thing is the damage modeling stuff. So as you can see, so user can check the damage with the damage material models available in the similar 3D experience. Metal and the concrete material models constants can be find out using the material calibration app. So as you can see, the material there is a damage plasticity is there. So concrete a damage model, you can find out this material calibration app. So there are the things are there you can find out the this constant with the material calibration application as well. So this is what you can see over here. Whether the damage model has been used for this stuff. So you can get the more crystal clarity about the how your model will behave while you compress this thing or whatever you want to do with your model. So it will like it will showcase you like this, like for example, you expand extract this thing like in this particular direction. So how it will break in this particular direction. So this is what we can perform using the damage modeling stuff. And this is what this Simulia the portfolio. So there are the three main packages there. The structural engineer is there, then structural performance engineer is there, and the durability mechanics engineer is there. So whatever I have showcased you today, which is nothing but the material calibration thing, and this material calibration thing is available only in the durability mechanics engineer role, which is the high-end role of this similarity experience. So in this similarity experience, you can see there are the variety of the analysis you can perform from linear static, frequency, buckling, thermal. Okay. The harmonic one, the harmonic response is there. Okay. The nonlinear analysis is there. Okay. And the explicit and the quasi-static random vibration. Okay. So all this type of analysis you can perform. Apart from that, also you have the capability. This software has the capability of the advanced matching. Like in the matching portion, not only the tetra mesh is there, but there is also the hex mesh is there. No doubt there is a you have to perform uh, different procedures to do this particular hex mesh, but this hex mesh is also available over here. Apart from that, there is a the you can say the smooth particle hydrodynamics is also there if you want to perform such as analysis you can say the bird strike. So in that SPH is there is also available. Okay, so Eulerian Lagrange method is there. So that thing is also available, but that thing is available on the high end role, which is nothing but the durability mechanics engineer role. Okay. Moving forward, I showcase that thing that these are the roles are available, and each role has some cores are connected. Like in structural engineer role, the basic role, which give you the 4 core capability, and the other role, the high end roles, like give you the 8 core capability. So 8 core you can use either in the cloud, and you can use that thing into the particular cloud or the local portion. And as I showcase you that you can perform this analysis using the cloud and the local thing, and you can use the token and the credit thing, which I have showcased you that thing in the previous slides. Apart from the structural portion, we have the capability of the fluid, electromagnetic, and the plastic stuff is there. So if you have any query regarding this any kind of structure, fluid, electromagnetic, and the plastic stuff, you can reach out our marketing team. You can reach out directly to us. Okay. So this is from the my side. If you have any query, you can reach out to the marketing team and we can have the one-to-one meeting. Thank you so much. If you have any question, you can ask us, and if you want one-to-one meeting, then definitely we can have the one-to-one meeting as well. Let me know if you have any question currently, or we can close this webinar. Anyone? I'll wait for the 2 minutes, and later on we can close this webinar. Okay, I believe there is a no question any of two. Just so I just close the webinar, and if any query is there from anyone, then you can reach out to us, our marketing team. Okay. Thank you. Thank you for joining. Thank you for your time.